So philosophers have often found mathematics especially puzzling and problematic from a philosophical point of view. Mathematics has some features that it's unclear how anything can have those features. So one of the things that is special about mathematics is that it's fully objective and it applies universally to everybody, independent of your cultural background or preferences, or so on and so forth. And that applies to other things too. But furthermore, it seems like you can find out about it by thinking alone. All you need to do is sit down, close your eyes and ears, and think about it. And that feature alone is puzzling enough. But so the philosophy of mathematics does many more things than just think about these general features. There are many other questions that people think about. So one of them, for example, is all mathematics ultimately unified? Is it all about the same thing in some general sense? All the different parts of mathematics, just separate areas that won't be unified in some sense eventually. Or are proofs that are aided by computers just as good as proofs that are done without computers, just on paper and pencil? Is there a crucial difference between a proof that shows that a result is true and a proof that explains why it's true? Is the goal of mathematics just finding out what's true or understanding how it all hangs together? And so on and so forth, for many other questions like that. Okay. All this what I just mentioned, that's sort of fancy pants mathematics, philosophy of mathematics. So you need to know some mathematics to do that. And all of these questions that I've mentioned are widely debated, and the answer is unclear. But my point for my 15-minute talk here will be that the philosophy of mathematics situation is much worse than that, in that it looks like we don't even know the answer to the most elementary and most basic questions about mathematics. That the most elementary and so trivial results in mathematics, once we think about those, it's unclear what they even say, what they're about, how we could come to know that they're true, and so on and so forth. And that this is a little bit scandalous, I want to suggest. So think about the most elementary, most basic mathematics that you can think of. So here's my example, that would be my example for this talk. I want to talk about this. Okay, now uncontroversially, this is correct. Okay, this is a true mathematical theory. But what does it mean? What does it say? And how do we know that it's true? So first of all, we should note that it's a symbolic, statement. It's written in a bunch of symbols, and these symbols, they're introduced. They're artificial symbols that we introduced somehow and given them some content. What does it actually mean? Now, if you just look at the symbols, it's unclear. But if you say out loud what you think this means, then you would say something that's not symbolic, that's in a natural language, that will have some determinate content, and then we can think about what is that content of what we say in ordinary natural language that's supposed to read out these symbols. And then we can think about what is that about, what does it mean, and so on and so forth. Okay, but here, the funny thing about this is that different people read this in very different ways. And there's systematically two ways of thinking about this, systematically two ways of reading this. One of them is, in one of its versions, 2 and 2 is 4. But you can also read it in the plural, 2 and 2 are 4. Similarly for other ways, 2 plus 2 is 4, 2 plus 2 are 4. 2 plus 2 make 4, 2 and 2 makes 4. 2 and 2 equal 4, 2 and 2 equals 4, and so on and so forth. So it looks like you can read this in the singular and the plural. Now, some people think that only one of them really is correct. That one of these, the singular or the plural, is really a misreading of this sentence, the symbolic one, and is in fact ungrammatical. Normally people say that the plural one is ungrammatical. You can't say 2 and 2 are 4, it's 2 and 2 is 4. Why is that? Well, because a number is a single thing, and this is about a number, and therefore, if it's a single thing, you must use the singular. But it turns out that that's a little bit of reading, forcing your grammar to fit your philosophy. Because if you, whether or not a number is a single thing is partly a little bit unclear in this context. So let me I'll get that in a minute. If you look at actual usage of 2 and 2 is 4 and 2 and 2 are 4, you can actually search, for example, all the books that are scanned by Google over the last 150, or published over the last 150 years. And in each year, the expression 2 and 2 are 4 occurs more often than 2 and 2 is 4. It's hard to argue that 2 into R4 is ungrammatical when it is more widely used than 2 into is4. Now when you switch it to plus, it's a little bit different. Then plus 2 plus 2 is4 is more, occurs more often than 2 plus 2 R4. But in any case, it's always the case that the singular and the plural ways of reading that, using plus or make or equal, all occur widely. So what's going on? Now let's look at each of those a little bit separately and see if we can figure out what's going on. So in a singular use, it seems pretty clear what's going on in some sense. When you say 2 plus 2 or 2 and 2, and the plus and, let's skip over well, that's the same difference. 2 and 2 is 4. What you're saying, it looks like, is that there's one thing here, the number 4. And this symbol here, and similarly when you read it out in English, 2 and 2 is 4, the number word 4 picks out that thing. It picks out a particular object, the number 4. And 2 and 2 picks out the same object, the same number, just in a different way. It says that if you add 2 to itself, then that 2 and 2 denotes an object, which is also the number 4. And the whole statement says that the object picked out by 2 and 2 is the same as the object picked out by 4. In this case, 4 is like a name for an object. It's like Fred. Whereas this 2 is a name for another object. It's like Sue. Now, if you think about it this way, then this statement talks about objects. It says of particular objects that when they're picked out in these different ways, it's the same object. So the next question you would have then is, what's that object? What object is that? Which is the number 4. That is denoted or referred to or picked out by this particular symbol. So could it be this chair, for example? And now it seems that obviously not. The number 4 is not this chair. But why not? Why can't the number 4 be this chair? And it seems absurd, but prima facie it's not clear why it couldn't be the chair, because all you're saying is that you're picking out a particular object with this number, and then you can wonder, okay, which object is it? Why couldn't it be this chair? And maybe the number 2 is the chair right next to it. Why is that absurd? It's not so clear. But most philosophers, I mean, all philosophers think it's absurd somehow to think that the number 4 is a particular material object. Those who think that the singular reading of this mathematical statement is correct and ultimately revealing what's going on, normally think that number words are names for objects that are not material objects. They're objects that are somehow existing outside of space and time, abstract objects in a technical sense. And that's what arithmetic or mathematics is about. Mathematics is not about some aspect of the material world, or at least not directly, but rather about some other part of the world, which is non-material, which is distinctly different from it. Outside, it's not spatial, it's not temporal, and mathematics aims to correctly describe what's going on with this particular part of the world. That's a certain picture of what mathematics is supposed to do, and what this particular statement is about when it's read in the singular. Now let's think about, though, what's going on if we read it in the plural. If you read it in the plural, 2 and 2 are 4, then it looks quite different. 2 and 2, in this sense, could be filled in a certain way, particularly in the plural reading, where, for example, you can say something like 2 dogs and 2 more dogs are 4 dogs. Now that was about dogs. I could also do that about cats. 2 cats and 2 more cats are 4 cats. Or I could sort of generalize and say, for whatever, 2 and 2 more are 4. Now when I use it in this sense, I need to use the plural. I need to say 2 cats are, etc., etc. The plural is required. But then when you use the number word like this, in the sense of 2 and 2 are 4, of whatever you take, the number word itself is not a name for an object. That's kind of like saying some cats and some more cats are a lot of cats. And so now the word some seems to be grammatically very similar to the word 2 when I say 2 cats and 2 more cats. 2 cats, some cats, same difference. So these words you might think are more like adjectives or determiners or modifiers, but not like names. They're only part of a full, singular term or noun phrase, but not themselves one. So in this reading, the plural one, the word 2, is not a name for an object. So 2 and 2 are 4, and In this sense, it's like some and some more are a lot. The word some is not a name for an object, just like the word a lot is not a name for an object. It just modifies a noun and tells you about how many of those. So suppose you think that that is what's ultimately going on. This really should be understood in the most revealing sense of what this statement is about as in the plural reading. 2 and 2 are 4. Then the number words are not names for objects. So what is the statement about? It tells you something about collections of things. Like if you have 2 things and 2 more things, then you have 4 things of whatever kind you're thinking about. But that seems a little bit problematic. Like what collections of things? Is mathematics just about collections of things? So for example, it might be that there are only finitely many things in the world. Right? But when I say those things and a couple more are even more things, then I can't be talking about any of the things that actually exist because there's only finitely many. So it looks like I don't have enough things to get all the numbers that I want. So that's one problem, right? So you might think that, oh no, it's just, don't worry about that. It's all about hypothetical collections. It's about that if you would have 2 things and you would have 2 more things, then you would have 4 things. Something like that. And that's what the arithmetical statement is really about. It's about hypothetical collections of things and how they could come together. But then mathematics is about, at least arithmetic is about some hypothetical things. And that seems to be not that objective. Generally, the hypothetical is not that objective. I mean, what would have happened if Napoleon would have lost or would have won in particular battles? That's, up for speculation, but it's hard to see that the foundations of mathematics, of the most basic mathematical statements, is about hypothetical things. In any case, for whichever view you take, it's unclear how you could come to know about this stuff by just thinking alone. So take the singular case, right? So how do you know by thinking alone that what's going on outside of space and time with these particular objects that you have names for is as you think it is? Right? It looks like these objects are not just really far away in space from you, but not even in space. So in some sense, even further away. In some sense, So similarly, suppose it's about hypothetical collections of objects. How do you figure out that what's going on with hypothetical collections? How do you figure out that this is always guaranteed to be true? That if you have a hypothetical collection of a particular magnitude, then you have another hypothetical collection of a particular magnitude, and so on and so forth. So the situation is that it's unclear which one the right view is, whether or not the singular or the plural of reading of this particular equation or mathematical statement is correct. And depending on which one you pick, you get a very different picture of what this is even about. And you get a very different set of problems about this kind of view and about how we come to know about it. But the situation in some sense is even worse, because it's not just that we have to decide which one is correct, the singular or the plural, because in some sense, both of them are correct. If you read it in a singular, you're certainly getting something right. It's not that one group of people that says, oh, the singular is correct, no, the plural is more revealing, that one of them is completely wrong. It's itself puzzling that you can read this both in the singular and the plural, that somehow both of those ways of reading this are available. But they're about very different things. So the question is, how does it all go together? Which one of those readings is correct? Why do both of them arise? And which one of them tells us what's really going on with this basic, most simple arithmetical statement? Now it turns out, I got 1 minute. It turns out that nobody really knows the answer to these questions. This is, and I think this is a little bit scandalous, this is an open question in some sense. People debate this. People have made different proposals about this. They sharply disagree with each other. They have very different visions, but it's the most simple, most elementary, uncontroversial mathematical statement that is unknown what is even saying or what it's about and how we come to know that it's correct. So with that scandal, I'll end